Which semiconductor power device out of the following is not a current trigger device? Here, thyristor is a current trigger device, triac is a current trigger device, GTO is also a current trigger device, but MOSFET is a voltage controlled device. So here the answer will be MOSFET. This triac is equivalent to two anti-parallel connected thyristors, and in MOSFET, the voltage input to the gate controls the flow of current from source to drain. Hence, it is a voltage controlled device. When a thyristor is negatively biased, we know that thyristor is a three-terminal, four-layer device with three PN junctions in between them. And these are the possible modes of operation for a thyristor: reverse blocking mode, forward blocking mode, and forward conduction mode. Now in this question, it is asked that when a thyristor is negatively biased, when all the three junctions are negatively biased, then thyristor will not be negatively biased. When the outer junctions are positively biased, means when the outer junctions are positively biased, then also the thyristor is not negatively biased. When the outer junctions are negatively biased and the inner junction is positively biased, then in that case the thyristor will be negatively biased. So here the correct option will be option C. When a line commutated converter operates in the inverter mode, it draws both the real and reactive power from the AC supply. It delivers both real and reactive power to the AC supply. It delivers real power to the AC supply, and it draws reactive power from the AC supply. So this line commutated converter is a full converter with firing angle delay greater than 90 degree. And this is used in regenerative braking mode of DC motor. So this line commutated converter delivers real power also and reactive power also. So the most accurate option here will be option B. It delivers both the real and reactive power to the AC supply. In DC choppers, the waveforms for input and output voltages are discontinuous and continuous, continuous and discontinuous, both continuous, or both discontinuous. We know the chopper is a static power electronic device which converts fixed DC voltage or power to variable DC voltage. So the fixed DC is continuous in nature and the output we obtain is discontinuous in nature. So here the option will be option B. The waveform for input voltage will be continuous and the waveform for output voltage will be discontinuous. In DC chopper, if T is the chopping period, then output voltage can be controlled by PWM by varying T, keeping T on constant, or by varying T on, keeping T constant, or by varying T, keeping T off constant, or by varying T off, keeping T constant. We know that in chopper, the voltage output depends upon the duty cycle alpha, which is equal to T on upon T. So this duty cycle alpha can be varied by the help of varying the value of T on. And this T on can be varied with the help of pulse width modulation technique. Hence we can say that the value of T, that is the chopping period, it is controlled by varying T on, keeping T constant. So the option which will be correct will be option D. By varying T on, keeping T constant, we can vary the chopping period of a DC chopper. The anode current flowing through a conducting SCR is 10 amperes. Now if the gate current is reduced to half of its value, then the anode current would be. We know that the gate current is used to turn on the thyristor, and once the thyristor is turned on, no gate current is required to maintain the thyristor in its on state. This anode current is totally dependent on the load connected through the thyristor. So the answer for this question will be 10 ampere. The anode current remains unchanged because it does not depend on the gate current. A single-phase bridge-type cycloconverter uses how many thyristors? 16 or 8 or 4 or 2 thyristors. So it contains 4 and 4 antiparallel thyristors, total 8 thyristors. So option B will be the correct option. In a single-phase half-wave rectifier with RL load and freewheeling diode, the SCR conducts from alpha to pi, 0 to alpha, pi to 2 pi, or 2 pi to 2 pi plus alpha. So here you can see a single phase half wave rectifier with RL load and a freewheeling diode. It is conducting from alpha to pi. So the correct option will be A. From alpha to pi, the SCR will conduct in the single phase half wave rectifier with RL load and a freewheeling diode. Option A will be the correct answer. A single phase half wave controlled rectifier has 400 sin 314t as the input voltage and R as the load. For a firing angle of 60 degrees for the SCR, the average output voltage is. So the average output voltage given by using this formula, that is Vm means 400 upon 2 pi 1 plus cos of firing angle. So 1 plus cos 60, that is equal to 400 upon 2 pi 1 plus 1 by 2. So it is equal to 300 upon pi. So option C will be the correct option here. For the circuit shown, the latching current is 5 milliampere. What should be the minimum width of the gate pulse to turn on the thyristor? Since we know for inductor, the expression for voltage is given as V is equal to L di upon dt. So to find the value of width of the gate pulse, we can write T is equal to L I upon V. So L is 0.4 here, I is 5 milliampere, and the voltage is 200 volts. So the answer you will be getting will be 0.00001. So that is equivalent to 10 microseconds. In a three-phase to single-phase cycloconverter, the number of thyristors used are 3 antiparallel to 3 more thyristors. There is a total of 6 thyristors are used. So option B will be the correct option. A chopper in which current remains positive, but voltage may be positive or negative, is known as chopper type C, chopper type D, chopper type A, or chopper type E. So here the answer will be chopper type D. Now, a PWM switching scheme is used with a three-phase inverter to reduce the total harmonic distortion with modest filtering, minimize the load on the DC side, increase the life of the batteries, reduce low order harmonics, and increase high order harmonics. So several PWM techniques are used in inverter to get good quality waveform of desired fundamental frequency and magnitude. It may not be possible to reduce the overall voltage distortion due to harmonics, but by proper switching control, the magnitudes of lower order harmonics can be reduced, often at the cost of increasing the magnitudes of higher order harmonics. The answer will be option D. A PWM switching scheme is used with a three-phase inverter to reduce the low order harmonics and increase high order harmonics. How many switches are used to construct a three-phase to three-phase cycloconverter? So total 18 switches are used to construct a three-phase to three-phase cycloconverter. So option D will be correct answer. The type of power amplifier which exhibits crossover distortion in its output is, so that class of power amplifier is class B, which exhibits a crossover distortion in its output.